Welcome back to Basic Exploit Development. In this section of the course, we're going to be covering the Crossfire exploit, which is a demonstration of multi-stage shellcode. Now, before we do anything, we need to make sure that we block external connections to port 13327 and 4444. The reason why is because we'll be opening a bind shell against this target, and we don't want any opportunistic attackers on the LAN or somewhere from the internet to be reaching these ports when we launch our exploit, because it would give them root access to the specific Kali Linux instance that we're running. Now, first, you're going to run two commands. iptables -a input -p TCP -- destination port 13327 / -d localhost -a drop. Now do that again for port 4444. Alright, now with these two rules in our chain, we will not have any external attackers be able to exploit what we're basically trying to exploit. So right now we need you to run on the Crossfire game. It's actually pre-installed in Kali Linux, by the way, so I didn't have to put in a course pack for that. So user/user games Crossfire, then Crossfire. Now start up Evans debugger edb you can ignore that. File, attach, and press play. Now go into your directory of whatever you saved. Press F7 to ignore that. And press play again. And let's take a look at our proof of concept. So it's going to send 4,379 A's after attempting to set up the setup sound function and then cause the program to crash, basically. This is included within your course pack. Python, Xfire. As usual, EIP has been overrun with 4 A's, as we can see here. And now we will go through the standard process of locating the exact location of which we can control EIP. So we will use MSF pattern create lane 4379 to generate a cyclic pattern. Also exit out of this with a Control C. Actually, you must detach the debugger. What is going on here? Alright, so we have generated a cyclic pattern. I'm sorry, I've been running multiple processes, and not to mention that 4,379 characters is a lot. It's a massive cyclic pattern, by the way. So no wonder it took so long. So now we modify our proof of concept. Our cyclic pattern, and then we're going to restart the game again. Alright. Just press OK to keep continuing to play. Press play again. And now we have this that has ended up in our EIP register. So we're going to use pattern offset to locate this pattern. So MSF pattern offset -Q 46 36 70 46. And we found an exact match at 4,368 A's. As standard in the exploit development process, we're going to go modify our proof of concept again to add crash equals 4,368 A's plus, backslash 42 B's plus C's times 4379 minus 4 minus 4368. Let's see if I got the math right. Yes. Oops. Made another. Screwed it up again. 2 X's right here. Alright. So let's detach the debugger. Can we restart it? Press play. And let's just check that it was working. Grep listen. Oh, it is. Okay. So for future reference, you can just simply debug, restart. So we're going to fire our proof of concept again. Python, fire proof of concept. Excellent. We hit our 4 B's, which is 4 B's have completely and cleanly overridden the EIP. Now, let's take a look at what's going on. Because if we now can control execution, however, if you take a look at the EAX register, follow and dump, you notice you have this strange setup sound function going on right here.